In today's lesson, we're going to move on from quadratic expressions to quadratic equations, which means, of course, that we're going to have an equal sign now. And in Algebra 2, well, in all algebra classes, we love to solve. So that's what we're going to be doing today. When solving quadratic equations, there's always a chance that you're going to have to square root both sides of the equation. And if you remember, when you square root both sides of the equation, on one side of the equation, the square and square root will cancel out. The other side gets a plus or minus. And you also might end up with a number underneath a square root. And since this is Algebra 2, we are still really concerned about simplifying things. And you might end up with an answer like the square root of 50, which is not simplified. So we're going to have to simplify that down. And you can break up square roots. If you look up here, the square root of a times b, you can rewrite it as the square root of a times the square root of b. So what we're going to do down here with the square root of 50 is we're going to rewrite it as the square root of 25 times the square root of 2. And the square root of 25, of course, is 5. Okay? So that's one of the things we would have to do if we ended up with a square root as an answer. And then over here on b, this is another problem. The square root of 5/11. So you never really should have a fraction underneath a square root. You should break it up and rewrite it as the square root of 5 over the square root of 11. And this is an issue for Algebra 2 because we have to simplify fractions. And there's a lot of rules for fractions. Like we can't have a negative in the denominator. We can't have a decimal anywhere in a fraction. We can't have fractions inside fractions, and we can't have radicals in the denominator. And a square root is a radical, so we have to turn this into a perfect root. Well, since it's a square root, we have to turn it into a perfect square, which would be 11 squared. So if I multiply top and bottom by the square root of 11, this value is just 1, so we can do this. That's going to make the square root of 11 squared, or the square root of 121, which is 11. And then we end up with that kind of answer there. All right, that's just a little review of Algebra 1 in case we get an answer like that. So remember, we are doing quadratic functions, and a quadratic function is a parabola. And when we're talking about functions, we really have to be thinking in the back of our mind, we're talking about graphs. And there's some really important things on graphs, depending on the shape that we're graphing. In parabolas, in quadratic functions, a couple of those things are vertex. We talked about that in an earlier lesson, and intercepts. All parabolas will have a y-intercept, and because it's a function, it can only have one y-intercept. But they also might have x-intercepts. I say might because if we had a function that opened this way, we have a vertex, we have a y-intercept, but we don't have any x-intercepts. So that might happen. And it actually you might end up getting just one x-intercept if the vertex lies right on the x-axis. So these are the three types of functions that could happen here, where we get one x-intercept, two x-intercepts, or no x-intercepts. So if you look down here at the zero product property, this little guy down here, I have two factors here. I have an a factor and a b factor. When you have two variables, you really can't solve for one. You can say, well, if b was any number and a was 0, it'd make it true. Or if a was any number and b was 0, it would make it true. So as long as either a or b is 0, you would have an answer to that. And then you put that in an ordered pair and you'd have your x-intercepts. So we're going to leave the graphing for a little bit. We're just going to deal straight with factoring and solving. And so there's a couple of steps that are new to us, and then a couple of steps that we've been doing all year long. So the very first step in solving quadratic equations is that you have to get the equation set equal to 0. You can't have stuff on both sides of the equal sign. You want all of your numbers and all of your letters on one side. I like to put them on the left. And the other side should be a 0. Now remember, we don't want x squared to be negative. So if you have to move the x squared to the right, that's fine. Just make sure that your x squared is positive and that all the stuff is on one side with that, and we can go from there. So the first step is to set everything equal to 0. And then you get to go through those questions that we've asked all year. What are we solving for? X. How many are there? 2. Are they like terms? No. And then so we're going to have to factor. And if you remember from our factoring, the first step of factoring is GCF. So we look at all 3 of these terms and we say, well, they don't have a GCF. So this is just going to be straight either the AC method factoring that we did or guess and check method. This is probably the easiest one to guess and check because this is an x squared. So we're going to go ahead and guess and check. What I would do is I would just write down my 2 sets of parentheses, and then I put the x first here, and we're just going to check Smile and George right here. We have to multiply to a positive 6. So that tells me both of my numbers that I put into the second part of those parentheses, they have to be the same sign. So, and when they're the same sign, I have to add the O and the I together to get the middle term. So I can use 1 and 6, 2 and 3. So this is a tricky one because 1 and 6 can make a 5, but it'd have to make a 5 by subtracting, which means the 6 over here would have to be a negative 6. Well, it's not. So it has to be 2 and 3. And I want a negative 5, so it'd be those guys. And I just slide them up here. And now I have 2 factors set equal to 0. So here's the last step that's new. You take each factor that has an x and set it equal to 0. And then solve. So x is 2 is a solution, x is 3 is a solution. And since we're not talking about a function right now and we don't have a y equals or an f of x equals, this is the answer. These aren't vertical lines because we're not in the coordinate plane. Let's go ahead and end this lesson on a little word problem here. This is talking about Mark Twain. Hopefully you guys have heard of that guy before. He's a pretty famous author. He did write this thing about the celebrated jumping frog of Calaveras County, where they had a little fair, I believe, and they won a prize for the frog that jumped the furthest. So we have this frog over here that jumps, and almost everything in our real world follows a parabolic type model because of gravity. So when you jump, you go up and you come down and you follow the same kind of thing. So we have a little modeling function over here that they said models this frog jumping, probably totally made up, but it's okay, it works for us. So this time we actually are talking about a graph, and so we have a y equals. Well, I want to know how far this frog jumped. Well, it started way down here and it ended way down here. Well, those are called x-intercepts. And we already know part of our answer for an x-intercept is something comma 0. Well, we're actually going to have 2 of them, so we're going to put 2 comma zeros. And if we just go ahead and set our function equal to 0, I put a 0 in here, and I do negative 0.029 x squared plus 0.59x. I got it set equal to 0, so I did step 1. Now I'm going to ask myself the questions. What are we solving for? X. How many are there? 2. That's bad. Are they like terms? Nope. That's worse. So we're going to have to factor. And remember, the first step of all factoring is GCF. And they do have an X in common. All right, so I got this. So there's my thing. And now I can set both of these factors equal to 0. So I got x equals 0. There's that guy. And then when I set this other one equal to 0, I'm obviously going to have to throw this in a calculator because I can't do this in my head. So plus 0.59 equals 0. And when I do all that, I think I get 20.3-ish feet. So that's right here. So that frog jumped 20.3 feet. Okay? All right, last question here. How high did the frog jump? If you look back at the last page, we had a parabola. It was opening down. That's why we have a negative a there. So when I talk about the vertex, that is called the maximum height, all right? Because it opens down, so the vertex is on top of the parabola. If it opened up, it would be a minimum, all right? So what we need to do is to find the vertex. And if it says how high did he jump, that's the y value of the vertex. But we can't get the output until we get the input. And if you remember from a couple lessons ago, it looks like this, negative b over 2a. And then I'm going to plug that into the function. That's all this fancy writing means, is plug it in. So I'm going to do negative 0.59 over 2 times negative 0.029. And that is going to give me 10.17. All right, so that's the input. So if I take my 10.17 and I put it into the function, and I square that, plus 0.59 times 10.17. I do all that, I'm going to get approximately 3 feet, right? So there's my vertex. So the frog jumped approximately 3 feet in the air. And that finishes this lesson.